Hi everyone. So this is going to be the Target 15 Part 2 homework review. Again, everything is listed by parts, so this will go with the Part 2 worksheet as well as the Part 2 section of our note packet. It's all dealing with the Pythagorean Theorem, which is the relationship between the length of the three sides in a right triangle. And then the equation that we're all familiar with is a squared plus b squared equals c squared. So in some way, shape, or form, we will use that equation in all of these problems to find a missing side. Sometimes that'll be it. Other times we'll do something else with that missing side we find. So here we go. In 1A, remember we are doing 4 specific problems that are actually on the Part 2 homework. So 1A, 4, 5A, and 6 this time. All right, so let's walk through these. All we have to do is find the length of the missing side in 1A. Missing side is labeled as x in this diagram. So to figure it out, we're just going to apply a squared plus b squared equals c squared. Remember, the crucial piece is which side is c. So find your right angle, look across from our triangle. That's going to give you the hypotenuse, which is the longest side, which is c. It always has to be that way. So x is our c side this time. So we just square the other two, add them together, and square root as the last piece. So 65 squared plus 72 squared is going to equal x squared, right? A squared plus b squared equals c squared. And so square those two, do the exponents first. So 4,225 plus 72 squared is 5,184 equals x squared still. Add those together, that's a big number, 9,409. That equals x squared. Remember, we want x, not x squared, so last step, square root both sides. It's okay to go to decimals, so when we do this, we get x equals, oh, and my bad, it's not even a decimal this time, it is 97. And remember, x is really our c side, so x is what we wanted. And just as a check, remember, c is always supposed to be the longest side, so since we know that side is 97, that's bigger than 65 and 72, which is a good thing. All right, now let's do number 4. We did a problem like this in our notes. So a ladder is leaning against the wall with its base 7 feet from the building. So I'm going to draw that again. I'm going to draw a brick wall because I'm good at it, real good at it. Here we go. Let's add some bricks. This is art, people. This is art. All right, now I'm going to draw a ladder leaning on the wall. Once again, put an artistic touch. It says it's a 25-foot ladder, so that is 25. It says it is 7 feet from the base of the building. So connecting basically the bottom of the building, that is 7. And again, it creates a right triangle with the building and the ground. And we are kind of wondering about how high up does that ladder go. So I'm going to put an X there. If our window is 22 feet high, the question is, can our ladder reach it? And so we want to solve for x. If it's 22 feet, then yes. If it's less than that, then no. So again, a squared plus b squared equals c squared. Find your right angle. 25 is c. And so we will start with x squared plus 7 squared equals 25 squared. Solve this. 7 squared is 49. 25 squared is 625. Subtract 49. So x squared is going to equal 576. And take the square root of both sides, and we get that x equals 24. Remember, it is feet, so 24 feet. So the question is, can the ladder reach a window that's 22 feet high if it's a 25-foot ladder and it's 7 feet from the building? And the answer is yes. Yes! Right? Because this ladder is reaching up 24 feet. Oh, I'm sorry. I do not even know what happened. Let's re-rotate that. This ladder is reaching up 24 feet. It only has to reach up 22 to get to the window, so it can definitely reach there. All right. Perimeter of an equilateral triangle is 30 millimeters. What is the height? Remember, we should draw that in. Our height is this imaginary straight up and down line. Creates a right angle with an opposite base. And so that's what we want to figure out. And we want to use the perimeter to do it. Remember, equilateral triangle means all 3 sides are the same. And so if the perimeter is 30, we want to divide that by 3 to figure out each side. So each side is 10. add that to our diagram. And just remember that on the bottom side, it splits our 10 in half. So each side of our imaginary line, which is our height, is 5 and 5. And that's important because that height creates a right triangle. We need a right triangle to do a squared plus b squared equals c squared. And so here's our right triangle, for instance, over in this diagram. Find your 90, go across from it. There's your c, so 10 is c, which makes h, and 5 are a and b. So we will do h squared plus 5 squared equals 10 squared. We just got to solve for this, and that's our answer, right? Because we just want the height. So h squared plus 25 equals 100. Subtract your 25. H squared equals 75. And then square root both sides. H equals, and the square root of 75 is roughly 8.7. And again, based on 30 millimeters as our perimeter, so height is 8.7 millimeters. And that is our final answer. Last problem. Rectangle has a base of 12 and the length of the diagonal is 15. What's the area? So area of a rectangle is simply just base times height. And so we know the base, it's 12, but then we know the diagonal. We need to use that information to find the height, and then we can do base times height for the area. So let's draw a rectangle. I'm just going to consider the bottom the base, so I'm going to write a 12 there. In a rectangle, remember, bottom and top would be the same, so the top is 12 as well. And then it says diagonal is 15. A diagonal connects opposite corners. That'll be a 15. Remember, every rectangle, 4 right angles. And that's crucial because if we look at like half of this rectangle, it makes a right triangle. And that slanted side's 15, the bottom's still 12. And then we'll consider that left side to be our height. And so if we use Pythagorean Theorem to solve for h, we can get our height, and then we can plug that back into our area equation up here. So find your 90, look across from it, there's our c. And so h squared plus 12 squared equals 15 squared in this situation. Solve for h. And 44 equals 225. And then we'll subtract. So h squared equals 81. Square root that, and we get that our height is actually 9 centimeters. All right. So let's go put that back into our original diagram here. The left side is what we solved for. Oops, not 8, it is 9. Remember, left and right are the same in a rectangle. And so the area is just base times height. Remember, base was 12. We just solved for height, which is 9. So our area equals 12 times 9, which equals 108. Units are centimeters still, and area is squared units, so 108 centimeters squared was the area of this rectangle. All right, those are 4 problems from part 2. Hope that helps. Keep working hard, and I'll talk to you in part 3. Thank you.